Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and in this video we are going to solve another GATE question. It was asked in the year 2008 for 2 marks, and it is related to the fork system call, right? So let's read this question. So the question goes like this: a process executes the following code, right? This is the piece of code that this question is referring to. So here you can see there is a for loop. It runs from 0 up till n. So basically the loop variable I will be less than n. So 0 till n minus 1, right? And in this for loop, there is only one statement, that is the fork system call. So what we are doing here, we are basically, it is basically n fork statements, right? It is in a for loop, right? Which is being executed n times. And the question asks that the total number of child processes created is, and here are your options. So basically, n is the number of fork statements that will be executed by this piece of code. N is the number of fork statement, we can say, that is part of this code, right? The number of times fork will be executed is a different thing, but n is the number of fork statements in your code. If you do not have this for loop, if you write it, if you kind of unroll this loop, then it is like n fork statements, right? So you have to quantify the total number of child processes in terms of n, right? And a very similar, almost exactly similar question was asked in the year 2004 for 2 marks. The only difference was that the loop variables started from, so I started from 1 and it went up till n, that is I less than equals to n. That is the only difference in that question. So it was a very similar question. I have attached the link, but again, we will discuss this question again, right? Although it is a very similar question, it has already been discussed in a separate video, but nonetheless, we'll discuss it here again, right? So let's just quickly recall what happens in the fork system call. The fork system call is used for process creation in the Unix operating system, right? So what it does is that when the fork system call executes, it creates a copy of the original process. It basically duplicates the parent process to create a child process, right? So here you can see an example. This is process A, right? And within the code of process A, there is somewhere there is a fork system call, right? So the flow goes something like this. The process starts the execution from the main, then it hits the fork system call. When we invoke the system call, the control is transferred to the fork routine inside the operating system. Whenever we make a system call, the control is transferred to the appropriate system call routine inside the operating system. So the fork routine, what does it do? It creates a new process, that is process B. And as you can see, the process B is a copy of the process A. It's an almost exact copy of process A, except for a few minor fields like the process ID. The new process that is created, everything is the same. The code that is being executed, the data that is being processed, everything is the same except for a few things, right? And once the fork system call is done, once the routine has been executed, it returns. And it returns twice. Once in the parent process, which is obvious, right? The parent process invoked this routine, so it will obviously return to the statement that follows the fork statement. Another peculiar thing is that the fork system call also returns in the child process, and the child process basically starts its execution from the statement that follows fork. This is how we create a new process in the Unix operating system using the fork system call, right? We have discussed about the fork system call in great detail in another video, right? So this was a brief description, a brief review of the fork system call, right? And now coming back to the question. So the question is basically asking that, let's go back to this piece of code. The question is asking that if there is a piece of code that has n fork statements, right? I'm saying n fork statements. I'm stressing on this fact because if you look at this piece of code, it's a for loop, but at the very basic level, right? It is just n fork statements, right? Because it helps us to think about this question in a more clear way. If the number of fork statements is n, then what will be the number of child processes that will be created, right? So we have already derived the formula for this in that separate video where we have discussed this. So if the value of n is 1, basically if there is one fork statement, if there is one fork statement in your code, then the number of child processes that is created is 2 raised to the power 1 minus 1, which is 1, right? So the rule here is that if there are n calls to fork, basically read this as if there are n statements of fork in your code, then the number of child processes or the number of new processes, total new processes that is created in the system is 2 raised to the power n minus 1, right? So if you use this formula, so here is this table. For value of n is equals to 2, the number of child processes will be 3. For n is equals to 3, the number of child processes will be 7, and so on, right? So what we will do, we will quickly go over the code once again and again see how this formula was derived. Although we have already discussed this, but let's once again do this, right? So this is the piece of code. Here I is the loop variable. It runs from 0 up till n minus 1, right? So I has to be less than n. So 0 till n minus 1. This is the range of the loop variable I. And all we are doing is that we are invoking the fork system call. So let's say this is the parent process. So n is, in this case, n will see will vary n, right? And see how many child processes are created. So let's say the value of n is 1, right? So this is equivalent to having one fork statement in your code, just one fork statement, right? So if that is the case, then what happens is that the parent process calls fork and a new process, that is this child process, is created. And when the fork system call returns from the operating system, it will return both in the parent and the child, and it will start executing from the statement after the fork. So after this fork statement, what will be executed? The loop variable will be incremented. So after returning from fork, the next statement that has to be executed is this incrementing the loop variable I plus plus. So in this case, the initial value of I is 0. So after incrementing the value of I, it will be 1. And what is the value of n in this case? The value of n is 1. And the value of I also becomes 1. So 1 is not less than 1. And in both the parent and the child, the loop terminates. So no more fork invocations will happen, and both the parent and the child process will terminate. So as you can see, if the value of n is 1, then the total number of processes in the system is 2, and the number of new processes, the number of child processes, is 1, right? So let's see the case when the value of n is 2, right? If the value of n is 2, then what will happen? So after the first fork system call, when the control returns to both the parent and the child, we said that the statement that follows fork will be executed, which is this incrementing of this I variable. So now after incrementing, the value of I becomes from 0, it goes to 1, and 1 is less than 2, right? We are talking about the case when the value of n is 2. So 1 is less than 2. So this loop will be executed for one more time if the value of n is 2. In both the parent as well as the child process. In both the parent as well as the child process, this fork will be executed one more time. And what will happen? We will have two new processes. This parent will create again a child process, and this child processes, which already was created, will create another new process. So as you can see, the total number of child processes in the system, if the value of n is 2, is 3. Right? We have total 4 processes in the system, out of which there is the one initial parent process, and the number of new processes is 3, right? Now let's see if the value of, so what will happen now? So now all of the forks, so now fork will return in all of these processes, right? It will return in all of these processes and resume execution from this statement, I plus plus. So value of I will now become 2 from 1, and this check will fail, that is 2 is not less than 2, and it will terminate, right? If the value of n is 3, so what you can see a pattern in what is happening here. So now let's talk about the case when the value of n is 3. If the value of n is 3, after the fork returns in all of these processes, and the execution is resumed from this statement, the value of I goes from 1 to 2. This check will succeed. If the value of n is 3, then only it will succeed. If the value of n is 2, it will fail, and the execution will terminate after this. But if the value of n is 3, this condition will be true, 2 is less than 3, and all these 4 processes will execute fork one more time. And as you can see, if the value of n is 3, the processes that 4 more processes will be created, right? So the total number of processes in the system will be 8, out of which 1 is the parent process, and the number of child processes is 7. So what is the trend that is being followed here? Every time we are increasing the value of n, every time we are increasing the number of fork statements in our original piece of code, the total number of processes is doubling. So if we had n equals to 1, that is if we had just one fork statement, then we have total 2 processes in the system, right? Out of which obviously 1 is the parent process. If the value of n is 2, that if we have two fork statements, then the total number of processes doubles, that is it becomes 4. If we had n is equals to 3, it again doubles, it becomes 8 from 4. So as you can guess, if the value of n is 4, then how many total number of processes will be in the system? It will be double of 8, which is 16. And out of these 16, if we exclude the original parent process, then the total number of child processes will be 15, right? So again, we can see the formula that we had derived in that video, in that earlier video, is true. So if there are n calls to fork, we can say if there are n fork statements in your code, then the total number of child processes is 2 raised to the power n minus 1. The total number of fork system call invocations, right? An invocation is different from the statement. The statement is just there in the code, but how many times will it be invoked? If there are n statements in your code, then the total number of invocations that will be there, that is this 2 raised to the power n minus 1, right? So the answer will be option B, which is 2 raised to the power n minus 1. So guys, this was it for this video. This is almost an identical question to the one that we discussed, that is 2004. It was asked for 2 marks. The only difference, as I said, was that in that question, the loop started from 1 and it went up till n. In this case, the loop is starting from 0 and it is going to n minus 1. The same question was asked, the same answer is there. So the underlying formula that is being that we're using here is that if the code that you have written has n fork statements, right, it could be inside a loop. If your the bottom line is that if your code has n fork statements, then the total number of invocations or the total number of new child processes that will be created will be 2 raised to the power n minus 1. So guys, this was it for this video. Thank you very much for watching. I will see you in the next video. Thank you.